NASA detected a mysterious object speeding toward Earth.
Hear about that fucking object that's hurtling towards Earth?
This may actually be a piece of alien technology.
A coronal mass ejection, one of the most violent solar eruptions in recent years. Blasted out from the sun at over 1 million miles per hour. It stabbed straight into the most talked about interstellar comet.
3I Atlas, this new object, in March 2026, when it will come very close.
Currently passing through our skies. A direct hit on 3I Atlas. The odds of this happening are less than 1 in 1,000. Now, astronomers are asking a question they never thought they'd need to ask. Did our sun just trigger something inside an object from another star?
Most important question is whether it could be technological or it's just natural.
Do you really think this is alien?
Yeah.
The universe breaks its pattern. In just 72 hours, the universe fired off what can only be described as a cosmic tantrum. First, 2 exploding stars lit up the night sky, naked-eye visible novas, bright enough to be seen without a telescope. That almost never happens. At the same time, Venezuela got slammed by 2 back-to-back magnitude 6 earthquakes, shaking cities and sending hospitals into blackout panic mode. And just when scientists thought that was the end of it, the sun launched a massive wave of plasma straight into space. And that wave hit 3I Atlas dead on. A solar storm, a real, live coronal mass ejection, didn't just fly past this alien object. It slammed into it. The only confirmed interstellar comet currently in our solar system. The odds of all this happening within 72 hours? Less than 0.1%. Some are calling it coincidence. Others are calling it a signal, a cluster, or just a pattern we don't fully understand yet. Scientists even gave this moment a name, the 72-hour stack. And now, telescopes are seeing signs they didn't plan for. Something hit 3I Atlas hard enough to change its behavior. And that was never supposed to happen. We've never had a moment like this before. We've never watched an interstellar comet get broadsided by a solar plasma burst. We don't know what the rules are for a collision like that. And it all begins with this one strange, fast-moving object from another star. There are only 3 interstellar objects that humans have ever confirmed. Just 3. The first one? Oumuamua, the long, cigar-shaped mystery that flew through in 2017. It didn't behave like any comet or asteroid we've seen before. No visible tail, no gas, just a strange, tumbling body that sparked more alien theories than answers. The second is Borisov, a bright, icy comet that passed in 2019. This one looked more familiar. It had a tail. It had gas. But its speed and trajectory still screamed one thing. It wasn't from around here. And now, we have 3I Atlas. Unlike the others, it didn't just slip through quietly. It showed up during solar max. And it's currently doing things no one expected. First 3I Atlas is moving at over 60 kilometers per second, which is way faster than most comets. And its orbit is not just weird, it's aggressively backward. Scientists call it strongly retrograde, meaning it's literally flying the wrong way around the sun compared to the planets and most comets. It's similar to traffic flowing one way on a highway, and then a semi-truck comes blasting through in reverse at 135,000 miles per hour. That's 3I Atlas. It entered our system at a steep angle, cutting across the plane of the planets, what astronomers call the ecliptic, and skimming close to Mars's orbit. On October 3rd, it'll pass within 0.19 astronomical units of Mars. That's closer than many expected. Close enough that even the teams running orbiters around the red planet have started prepping cameras and instruments. Everyone wants a look because it's currently carrying the oldest ingredients in the galaxy. 3I Atlas is made of stuff that predates our Sun, and this is not an exaggeration. Interstellar objects are believed to have been ejected from their home star systems billions of years ago, flung into the void during the early chaos of planet formation. These fragments could hold chemical signatures we've never seen before. The comet's ice, dust, and gas might not match anything in our solar catalog. This is the first time in history we've been able to observe an interstellar object passing through during a solar maximum, the Sun's most violent and unpredictable cycle. Normally, comets from outside our system show up and leave without any major drama. But 3I Atlas has arrived right when the Sun is throwing daily temper tantrums, hurling SEMs, surging sunspots, and heating up solar winds. This brings us to what scientists expected it to do, and what it's actually doing. 3I Atlas was supposed to brighten slowly. Comets heat up as they approach the Sun, releasing gas and dust and forming a coma, a glowing envelope of material. Astronomers charted the path. They predicted when the tail would form, when it would peak, when it would dim. But that model broke. After the CME hit, the coma didn't behave normally. There were irregular surges in brightness. Some areas flared, others faded. The tail began to show signs of unexpected turbulence, like the solar wind was pushing against something more volatile than usual. This wasn't a steady rise and fall. It was chaos, and we don't fully understand why. This comet is moving so fast, and its material is so alien, that even our best simulations are struggling to keep up. Instruments that are usually calibrated for Earth-native comets are throwing up weird data points. Color signatures, gas compositions, even the shape of the coma. It's like we're looking at something brand new every 48 hours. Did the CME change it permanently? Because if it did, we just witnessed the first real-time experiment between the Sun and an alien object. The CME that changed everything. The Sun pulled its most dramatic move yet by launching a coronal mass ejection straight into the path of 3I Atlas, a full-on high-speed collision with one of the rarest objects in our sky. And the timing could not have been worse. To understand how wild this is, you first need to know what a coronal mass ejection actually is. A coronal mass ejection is not just some gentle puff of solar wind. It is a violent, chaotic blast of charged particles and magnetic fields, flung from the Sun's surface at millions of kilometers per hour. It's the result of magnetic lines snapping and reconnecting like an invisible whip. When that snap happens, it throws billions of tons of plasma into space. Think of it like the Sun sneezing fire into the solar system. Normally, these ejections head toward Earth, or just into empty space. But this time, one of the most powerful ejections of the season barreled straight toward a comet from another star. And the Sun picked the worst time to go rogue. Right now, we're at the peak of solar cycle 25. This is when the Sun goes into overdrive. It spins faster, forms more sunspots, and fires off more coronal mass ejections than usual. Space weather forecasters have been tracking an uptick in solar activity for months. Sunspot numbers have surged above 160, and the solar flux index is holding steady above 180. That's the kind of environment where storms are not just possible, they're frequent. This particular coronal mass ejection was launched on September 24th, triggered by a magnetic eruption near one of the Sun's most active sunspot regions. The mass of the ejection was estimated in the billions of kilograms, traveling at speeds over 1,000 kilometers per second. Space weather models tracked its trajectory, and within hours, one thing was clear. It was going to intersect directly with the orbital path of 3I Atlas. This was a direct line, and soon it became official. The plasma wave was on a collision course. Scientists scrambled to update models. Solar physicists at NOAA's Space Weather Prediction Center pushed out alerts. Instruments from NASA and ESA confirmed what everyone feared. The comet would be in the middle of the blast zone right as it passed through one of the densest parts of the inner solar system. The window of impact was about 8 hours. No one had ever seen this happen before. Not to an interstellar comet. Not with this kind of solar energy. Every model we have on comet behavior was built on solar system comets. Comets that were born here and know how to behave under our sun's tantrums. But there, I-Atlas came from somewhere else. A place with different stars, different heat, different rules. And now it was about to take a punch straight to the coma. Scientists and telescopes around the world locked on. And the moment the coronal mass ejection reached it, everything changed. This was a cosmic accident that turned into a golden opportunity. The comet, the storm, the timing. None of it was planned. None of it was repeated. And now we get to ask a question we've never had the chance to ask before. What happens when plasma hits an alien object? When a coronal mass ejection hits a regular comet, a few things usually happen. The heat and radiation can strip gas off the surface. The tail might ripple or bend. Sometimes you get a temporary flare in brightness. But all of that is based on what we've seen with comets from our own backyard. 3I Atlas is not from here, which means everything is guesswork. And even when that solar storm slammed into it, the first signs were strange. The tail shifted, but not just bent by the solar wind like usual. It warped. Sections of it twisted and separated. Some astronomers noticed what looked like a kink in the plasma tail, almost like something had snapped. That's not typical with a coma like this. Then the light curves started to change. Telescopes tracking its brightness noticed sudden spikes. They were mostly short and sharp jumps, the kind of fluctuations you don't usually see unless something very hot or very volatile just happened. And that's just what we could see from Earth. Inside the coma, inside that glowing cloud of gas and dust, the chemistry may have shifted. The heat and charged particles from the coronal mass ejection could have triggered chemical reactions never seen before in space. Some researchers believe it may have sparked the release of rare volatiles, frozen compounds locked away in the nucleus of the comet since before our solar system formed. Others worry it may have done the opposite. Destroyed surface ice, stripped material, or even cracked part of the nucleus. If that happened, the comet could become unstable, fragment, break, or worse, become unpredictable. One theory gaining traction is that the coronal mass ejection might have altered the trajectory of 3I Atlas, even slightly. The comet is traveling fast, but it's also light. If the storm carried enough energy, it could slow it down, shift its spin, or tilt the path just enough to cause problems later. That's not confirmed yet, but orbital analysts are running fresh simulations every hour, just in case. Some of the instruments tracking the impact picked up magnetic field distortions as the coronal mass ejection hit. That suggests the comet interacted with the plasma in a deeper way than expected. It didn't just absorb the energy, it pushed back. Or at least, it reacted. Could there be iron? Metallic traces? Something dense enough to distort the incoming field? Dr. Stefan Burns, a geophysicist who's been studying solar interactions with planetary bodies for over a decade, was one of the first to call 3I Atlas something new. His theory is simple but brilliant.
we had this weird seismic swarm in Greece.
Since 3I Atlas came from another star system, it's built differently, which means when it gets hit by something like a coronal mass ejection, it gives off different responses, different gases, different particles, different energy curves. Studying that moment, the exact second the storm passed through, could tell us more about interstellar chemistry than years of lab simulations. He believes that this is the cleanest plasma testbed we'll ever get, and that this could be just pure alien material reacting to the sun. And right now, dozens of observatories are doing just that, looking for every single signal that could hint at what just happened. The unanswered questions. There are moments in science when the questions are extremely hard to answer. This might one of them. Even after all the tracking, all the equations, and all the predictions, we still do not know what exactly just happened to 3I Atlas. We know it was hit. We know it was timed within one of the strangest 3-day windows ever recorded in astronomy. But beyond that, the story is still writing itself. Since the coronal mass ejection passed through, telescopes have picked up small but noticeable changes in the comet's behavior. The brightness has spiked more than once. The coma has shifted. Several observatories have flagged irregular gas releases. Some of it expected, most of it not. These kinds of changes can be natural. Comets get more active as they heat up. But the timing is what keeps gnawing at researchers. These shifts started right after the impact, almost immediately. That's not normal. Why now? Why this exact 72-hour window? 2 naked-eye novas, back-to-back earthquakes in Venezuela, and a solar storm slamming into the only confirmed interstellar comet in our sky. These events do not have an obvious connection, but they happened together. And that alone is enough to raise eyebrows across scientific communities. There is a term for these kinds of strange alignments. It is called statistical clustering. Basically, randomness stacked in a way that feels planned. The kind of pattern that keeps people staring at their data at 3 in the morning. Some researchers believe it is just cosmic noise, a rare hand dealt by chance. Others are not so sure. Could there be a chain reaction in space weather we do not understand? Could novas and coronal mass ejections be connected by deeper cycles, driven by galactic forces we have not even mapped yet? If something like 3I Atlas was affected this way, the future for interstellar objects remains very uncertain. There are already programs scanning for more visitors like it. But what if they do not behave the same, and instead the next one shows up during a quiet solar period? Will we still get the same reactions and same signals? When you zoom out, this looks like a cosmic alignment. There are stars exploding, ground shaking, and solar plasma flying. And right in the middle of it all, a piece of another star system passing through our own. What comes next? The story of 3I Atlas is still unfolding. It has not passed perihelion yet. It has not made its closest approach to Earth, which means its biggest moments might still be ahead. Here is what is being speculated. In a couple of weeks, the comet will reach its closest point to the Sun. That is called perihelion. It will swing within about 1.36 astronomical units, which is a bit farther than Earth's distance from the Sun. Depending on how it reacts to that heat, we could see another flare in brightness. Maybe even fragmentation. Then, in December, it will become closest to Earth. Still far, but close enough for amateur telescopes to pick up details, especially if the comet remains active. Between now and then, global observatories are on full alert. The Rubin Observatory in Chile is locking in nightly scans. NASA's Mars orbiters are prepping instruments for the comet's close pass by the red planet. And solar physicists are watching the Sun for more CMEs that might cross its path. This is now a full-scale watch event. And it is not just the professionals. Community scientists, backyard observers, amateur astronomers, citizen space trackers are all being asked to join in. Sketches, time-lapse photos, brightness estimates, and tail changes are all being submitted to comet databases around the world. Every piece of data helps. This is science unraveling in real time. This might be the only chance we get to watch an object like this take a solar hit. We may never get another interstellar visitor during a solar maximum in our lifetime, let alone one that reacts so strangely, so publicly, and so fast. The solar storm was not planned. The nova explosions were not expected. The comet's path was known, but its behavior was not. Somehow, these moments collided and gave us a glimpse into how something truly alien might respond to our star. A collision we were never meant to see. A comet from another star system made of materials older than the Sun. A solar storm launched at the exact moment it passed through. And in the middle of it all, signs that something changed. 3I Atlas is flaring, warping and reacting in ways that don't match any comet we've ever seen. The timing and behavior is unreal and unstable. If the Sun just triggered a physical or chemical response inside this object, then we may be looking at the first recorded interaction between solar plasma and interstellar material, and the data could change everything we thought we knew about both.